Good afternoon, everybody. Welcome to another exciting afternoon of Chem 1105 with your host, me, Dr. White. All right, got a lot to do today, so I better get to it. Let me remind you, on Thursday, I'll be giving test number 1. I'll send out the password about 8 a.m. You'll have Friday until Friday, 4 p.m. to take test number 1. Upload your answers as a single PDF file to the assignment area Blackboard. There's an announcement about test number 1. I talked about it yesterday. And later today, I'll do a review for test number 1. All right, today's game plan. First, we're going to do the lab. Oh, some dust up there, top of my monitor. First, we're going to do the lab. After the lab, I'll do the review for test number 1. And then after that, if there's still time, which there might be, we'll go back to chapter 4, part 2. So let's look at today's lab. But before we do, remember, hand in labs. There's a lab due today. It's 10 points. They're not hard 10 points, but you get 0 points if you don't hand in a lab. Also, don't forget to include a selfie of you with some piece of equipment or a chemical with today's lab or one that's due today with that lab. All right. Let's talk about today's lab. And today's lab is called Exploring Chemical and Physical Changes. And this, I think you'll have a good time and have some fun with. Now, the question is, you'll be doing a series of experiments, mixing things together. Ooh, that's going to be fun. That you will have to determine, is there a physical change happening, a chemical change happening, or nothing happening? And you'll be doing this. Now, you'll be handling some hazardous chemicals. It's important you wear your goggles, your gloves, and either an apron or I'd wear a long sleeve top. All right. Don't forget to do the selfie. Now, when you mix two things together, does something happen? And when we talk about just in general things or stuff or chemicals, there's two types of changes, which I've already talked about. One is a physical change, where something changes its appearance, but not its chemical composition. Example of a physical change would be ice melting to liquid water. Both ice and the liquid it melts to are both water, H2O. Now, a chemical change involves making something new that has new physical properties and new chemical properties from what you started out with. Now, how do you know just by visually looking at something has a chemical change occurred? Well, here are 5, and really in chemistry we think of 4, but they put in production of light. Today's lab, you're not going to mix anything that will produce light. Oops, I gave it away. But you will have things. First thing, how can you tell if you have a chemical change? And let's try an experiment, not a chemical one, but a teaching one. And it worked. All right, now let's look at, well, I doesn't want to do that. The PDF file is in Blackboard, and let's find out. That's a good question. Thank you for your question. And right now I'm going to open up Chem 1105. Let me do something smart. Sometimes I do that. And I'm in student view. All right, let me make sure you can see it. You can. And now, if we click on assignments, scroll down, and you can't see it. Oops. I thought I said, hold on. Thank you. Well, that's not what I want. That's what I want. Come on. But I set it to visible. Ah, I forgot to change this. Hold on, let me make sure I'm the right. Yep. You get to see some real top secret stuff now. All right, now next Tuesday is the 4th of July. Happy 4th, which we won't have any classes. So I'm going to make this lab due on the 5th of July. All right, let me do one more thing. You can see all the neat things Dr. White gets to do in Blackboard. Let's go back to student view. Let's try this again. All right, let's go to assignments. And there it is. Okay, so you can now download this PDF file. By the way, Yulia, thank you for finding my error. You can see it now, yay! And I have another student show up. So we got a whole total of a lot of people. All right, we're talking about today's lab. I didn't have it set up properly on Blackboard. Now we do. So let's continue. All right, we're talking about how can you tell what are the signs if you have a chemical change. The first sign is you see a production of a gas. If you mix two things together and you see a gas, which you also know as, I can spell it right, bubbles. If you see bubbles form when you mix two chemicals together, you have a chemical change. Now, if you mix two things together and you see a precipitate, And a precipitate is a fancy word chemists use for a solid form. And they call it insoluble solid. Well, if you have a liquids and you see a solid, it's insoluble. And what does this look like? And let's go out to the internet, because I have a neat way of showing what a solid would look like in a liquid. And how many of you have sisters? I never had, my sister did have. Let me make sure you can see this. And you can see the globe right here and see the white snow inside if you shake it up and it starts falling down. Well, chemists would call that a precipitate. And if you see a solid formed in a liquid like those snowflakes, when you mix two chemicals together, guess what? That means you've had a chemical reaction. Next one, they talk about light production. None of the experiments you're going to be doing today involve making light. But if you've ever seen fireflies, I haven't seen any this year yet. Every once in a while in my backyard, you'll see a bunch of them, and I just sit out there and watch them, totally enthralled in what I'm seeing. That's a chemical change. Fireflies make light by a chemical change. Now, the next one, which then these are the ones that you should look for in today's lab. If you have a gas form, bubbles. If you have a precipitate form, next one is production of heat, and the last one is a color change. Let me talk about production of heat. What does that mean? If you mix two things together and it gets hot or cold compared to where it started, I guess I should say hotter and colder, you have a chemical change. How can you tell that? With a thermometer. If the temperature goes up or down from where you started, before you mix the two together, you measure the temperature of both things you're mixing together, and it gets hotter or colder, that's a chemical change. Now, the last one that's a sign you have a chemical change is if you have a color change. Now, they add further, cannot be explained by simple combination of two colors. If you take something that's blue and something that's yellow, mix them together and you get a different color, that's not a chemical change. If you mix two things together that are clear and all of a sudden it goes red or blue or yellow or green, you've had a chemical change. Or if it's gone black. So let's go through what you're going to be doing, and I'll talk about the actual lab in a second. You will be mixing things together. You'll check to see, were there any bubbles formed? You'll check to see, was there a solid form, which we call precipitate? You're not going to see light form, so don't worry about that. With a thermometer, you'll check that it get hot or colder. In the lab, we also just do it by holding our hand, but a thermometer is better. And finally, when you mix two things together, did you see a major color change? Now, if you have something blue and say you were to add water to it and it's a lighter blue, that's not a color change. We're talking about really major color change. Now, here are the different items you'll need from your chemical or chem kit, lab kit. Now, let me talk about a couple of the chemicals. Hydrochloric acid, where it says solution HCl 1M. I'll teach you later in the semester, 1M means 1 molar, that tells the concentration of the hydrochloric acid in water. I'll teach you about that later when we get into solutions. And the sodium hydroxide solution, NaOH, 1 molar also, those are hazardous chemicals. Hazardous chemicals should never be feared, but should be handled carefully. This is the reason why you should wear your safety goggles and wear your gloves. I highly recommend before and after, even with wearing your gloves, you wash off your hands. I would if I worked with that stuff. Now, interesting, they have phenolphthalein where they say it's a carcinogen. Well, it's very mild. Phenolphthalein for many decades used to be the active ingredients in X-Lax, which is a laxative that makes you go. In fact, you don't want to get a chemist mad at you, because if they ever do, they can always give you brownies with phenolphthalein in there. And oops, that's not going to be fun. You shouldn't do that. All right. Now, the magnesium ribbon, be very careful with that. Keep that away from any heat. Have you ever seen the old movies, World War II, where someone shoots a flare up into the sky or a little thing, and there's a parachute, and at the bottom of the little part of the parachute, there's this burning metal that lights up the sky? That's magnesium. Magnesium will burn very hot, hotter than anything your oven can ever get to. So keep it away from a flame or heat. You'll be putting it into a solution and it'll be fun. Now they have here, bottled or purified should be used to remove most solids from tap water. You can use regular tap water for this lab. And again, don't eat or chew gum or drink while you're doing this lab. Wash your hands before and after. Now, because of the chemicals you're using, I don't get kickbacks from this company. I wish I did. I would highly recommend you go to a big box store. I just happen to pick on Walmart, and this 13x9 aluminum cake pan, and you actually get 2 of them, are only $1.24 plus tax, which is a good deal to protect your counter in your kitchen if you're doing it. I would be very careful. I think marble will react with hydrochloric acid. I'll have to look that up. I don't have a marble top in my kitchen. But if I did, or even the top I have, I would do all the mixing and everything in one of these trays. Now let's find out. Let's go somewhere. We're going to, as my best friend has his joke, that French store, Target. That's his personal joke. He always says that. He's got me trained now. Target. And the ones at Target are more expensive. Whoa. So I just helped you save some money. Don't go to the French store. Go to the other one if you want to save money, or check Jewel or other places too. I'm sure they have them. But anyways, I highly recommend for today's experiments, you do all the mixing and everything in one of those aluminum trays. So if you miss a little and drip on something, it won't harm your countertop if you're going to do this in the kitchen. Now, let's look at today's lab. You're going to have a series of activities, and I'm not going to read every one, but let's look at activity one. You'll have your 2 test tubes, you have your inexpensive paper rack, and use your graduated cylinder and add 2 milliliters of the 1 molar hydrochloric acid to 1. And then enrich the graduated cylinder, and you can use just regular sink tap water a couple times, and then add 2 milliliters of the 1 molar sodium carbonate solution. Now, record the color, take a thermometer, measure the temperature of both solutions, and then you mix one into the other and watch. And then after about 30 seconds or a minute, you will measure the temperature. Now, let's look at step 8. It says combine the HCl solution tube 1 with the sodium carbonate Na2CO3 in a test tube. And here's the part I want to talk about. Gently swirl them to mix. Trying to find something that would be, all right, pretend this is a test tube. You got to use your imagination sometimes. Dr. White's class. Oh, that was a bad joke. All right, hold it like this. Never, ever mix a test tube like this. Never, ever. Because you're going to get chemicals maybe on yourself or someone else walking by. Here's how you mix it. Hold it firmly in one hand. Remember, this is your test tube. Take 2 fingers and go 1, 2, 3, 4, 5. That will mix it quite well. Now, look closely. Hold it firmly. Go 1, 2, 3, 4, 5. If you don't hold it firmly, it's going to go flying out to the other side of the room. Also, don't tickle it. That's not going to mix it either. You gotta go 1, 2, 3, 4, 5, and that will mix it. So remember, when you're mixing a test tube, never, ever shake it like this. Never do that. Don't forget, you should have your safety goggles on, gloves for today's experiments, and probably the apron wouldn't hurt either. Now, when you're doing any of these activities, like in step 2, activity 1, add 2 milliliters. Don't spend 20 minutes trying to get exactly 2. If you're a little above the line or a little below, that's okay. But if you're supposed to have 2 milliliters and you have 10, well, pour some back. Or if you're at 1, pour a little more in. And what you'll do is record it. Now, all these where you have a liquids, what you'll do is what's ever left over after you pour it, and whether reaction or not, you'll take your 250 ml plastic beaker, and that will be your waste beaker for today. Pour the liquids in there. At the end of today, all the liquids in that 250 milliliter beaker, pour down your kitchen sink, and then let it rinse with water for about 3 to 5 minutes. All right. In activity 2, you'll place 2 test tubes in a rack. One, you'll add about 10 milliliters of water using your graduated cylinder. The other, you'll add 0.3 grams of pre-weighed sodium polyacrylate to the second test tube. I don't have it in here right now. Hold on, let me get something. I forgot to bring it. I'll be right back. Good news, I'm back. Now here they say weigh out 0.3 grams of a pre-weighed. I don't know if you have in your kit pre-weighed or you have to weigh it yourself. You have to weigh it yourself. Don't forget your balance. Turn it on. Make sure it says gram. If not, push this button until you see a gram G there. Mine's not on. Waiting for it to get to 0. And if it's put the weigh boat on, hit here, and then weigh in your, if you don't already have it pre-weighed, your 0.3 grams of the sodium polyacrylate. Now, to put this in a test tube, squeeze the ends up and just tap it right in the test tube. And this one, if you're a little over like 3.2 or a little under like 0.28, that's okay. But if you're supposed to have 0.3 grams and you're at 6, no, that's too much. All right. Now, this stuff is really cool, and I'm going to give something away, but I think I should. What you'll do is take the water and add it to the sodium polyacrylate. And you can insert the thermometer and look what happens. Now, I'm going to give it away. Now, this product is going to be a semi-solid or solid, and just put it in your garbage can. Now, what is sodium polyacrylate? Well, I've actually done some consulting for a company that made that. And that's the material you find in super absorbent diapers and super absorbent women's feminine hygiene products that absorbs the liquid, mainly water. And this stuff is amazing. And when the company I worked for, I consulted for, was the company that invented this. And it was a couple months before their patent was going to run out, where they then would no longer have exclusive right to use this chemical, and other people could start making it and using it. And so they sold off that business, that part of the business, for, I forgot, $6 or $7 billion. Yep, B with a billion. This is a major industry. Next time you see a super absorbent diaper, or if you see advertised super absorbent women and feminine hygiene products, that's serious chemistry. All right. And I can go through the rest of the activities. 3, I'll be mixing stuff together. Same thing, 4, 5, 6, 7, 8, 9, 10, 11. How many are there? 12. And what you'll do is all the things that are totally liquid at the end of the experiment, you'll put it in your 250 plastic beaker. All the solids, if you form a solid, can go in your garbage can. Dump that down the sink. Now, notice they say flush with copious amounts of tap water. I'd let it go for 3 to 5 minutes. Me personally, I'd let it go 5 minutes, maybe even 6. And then you can rinse out any of your equipment, let it dry, and return it to your kit. Now, let's look at, and I don't have it open. So I better open it. All right, on your screen, this is a lab report, which you can download from Blackboard. And in here, essentially, you have one table. And let's look at activity 1. Initial color of the items, clear, whatever. final color, initial temperature, final temperature, observations. And what I would suggest you put in there, did you see a precipitate form? Oh, by the way, in chemistry, PPT is shorthand for precipitate. And did you see gas form, bubbles? Did you see, let's see, gas form, bubble, that's bubbles, precipitate? Did you see a temperature change? Or did you see a color change? You're not going to see any light formed any of these activities. That's expensive chemicals. They're not going to give them to you. If you see any of those four things, what type of change? And the answer would be chemical change. If it didn't, then that's a change physical state, like a solid dissolving in something, or a liquid to solid, solid to liquid. That's a physical change. And explanation, you can say, well, I saw bubbles form, or things like that. And that's today's lab. Remember, this lab is due Thursday. But because it's a long lab, I'm going to extend that till Saturday evening, which means I better do the following. Since this is such,
Professor, I have a question.
yeah, please call me Dr. White, not
Oh, I'm sorry, Dr. White.
sorry, it's just my preference.
So if we don't have any chemical change for the lab, can we just put it's a solid? You just want us to put it's a solid, no changes?
Wait, say that again. If you see a solid,
Well, so you told us for the observation, if we see gas, bubbles, or change of color, then that's what we would put down for observations.
right? And if you see a solid or precipitate form, you should put that down as a observation.
Okay.
And
Okay.
then you can say, well, I saw a solid form, and that's chemical change.
Okay.
You know, just something indicate. I'm not going to be looking like, how can I take off points? That's not my way. But if it's wrong, guess what? I will take off points. But I'm doing it in such a way. What I'm doing right now, so I remember to do it, is change the due date, because there's a lot of things to do for this lab. I'll make it until here, I'll do it Saturday, by the end of Saturday. So since this is a long lab, this will give you a lot of time to do that. And I think I just put the wrong date up here. That's the right date. So because it's a longer lab, I'll give you extra time to do it. All right, any questions about today's lab?
No, I think you went over everything.
Good. Thank you. And thank you, Yulia. All right, let's look at today's, we'll do test number 1 review. Now, before I do this, let's go back to Blackboard. Let's go to course information. And you see the 3 folders: lectures, recommended problem sets, and recommended problem set or answers. Let's click on lectures. If you scroll down, you'll see test number 1 review. And also test number 1 important information. Now I'm looking here, I don't know where it disappeared to. Later on, I'll put test number 1 review. I thought I uploaded it as a Word document also. I have the PDF file. So today's what you're going to see, the file that's called Chem 1105 Test 1 Review is in the lecture section of the course information of Blackboard, but you got to scroll way down near the bottom. All right, let's talk about test number 1 review. All right, first of all, you should know that there are 4 branches of chemistry, and you should be able to name at least one of them. And the 4 branches are organic, physical, analytical, inorganic. And you can see Dr. White's biased because the best is organic. That's why it's first, because I'm an organic chemist. I never did like inorganic. The other 2 are nice. All right, let's talk about matter. What is matter? You should know that's anything that has mass and occupies space. Now, next I have chemical symbols, and it says know 37 chemical symbols. And let me open up something real quick. And if you look in chapter 1, page 7, these are the chemical symbols for the elements you should know. You should know H is hydrogen. You should know I is iodine. You should know, oh, one of my favorite, because I used a lot in grad school, AR is argon. And you should be able to, if I ask you, give the chemical symbol for platinum, that's PT. What's the name? You should also be able to do of the element with the chemical symbol Ni, nickel. What is the name of the chemical or the element with the chemical symbol, I don't know, Fe, iron? What's the chemical symbol for silver? Ag. You should know these 37. I haven't asked you to learn the whole periodic table. Thank you, Dr. White. You're welcome. But these are 37 we use in our daily life, especially O, oxygen. Oh, that reminds me, time out. This morning I was out, or late morning, I was out doing some yard work in my backyard, and it was beautiful except for the smoke and the air from the Canadian fire. It cleared up for a while I was out there, and the wind was out there, and the wind was hitting me very nicely, and it felt good. And I realized, I wonder how many people know that when you feel the wind against you, wasn't that hard, but nice wind, that those are molecules of oxygen and nitrogen hitting you very fast. And that's the wind. That's chemistry. Molecules are chemistry. All right. Now, know those 37 elements. I'm going to have to get this. Hold on 1 second. Sorry about that. It was my dentist calling, trying to get into an emergency problem I'm having with one of my teeth. Life goes on. By the way, Yulia, after class, I'll upload the Word document for test number 1 review. And see, I put it on a Post-it so I won't forget. You're welcome. All right, let's get back. Next, you should know the 3 states of matter. First one, solid. Second one, liquid. Third one, gas. You should know a solid has definite shape, definite volume. You should know a liquid has indefinite shape, but definite volume. Remember, everything you see on the screen here, you can download as right now, a PDF file, later today, also as a Word file. You should know a liquid has indefinite shape, but definite volume, and you should know a gas has indefinite shape, indefinite volume. Again, solid, liquid, gas, and what they have, their physical property. Everybody got everything written down yet? All right, next, types of matter. Now, they're pure substances, and those are the elements, are pure substances, and compounds. An example of a compound would be water. Now, when we mix 2 things together and you have a mixture, you can have 2 types of mixtures, homogeneous and heterogeneous. Homogeneous means it's the same throughout. Example of that, the air you're breathing. If I go over and by my door, the amount of nitrogen, oxygen is the same as right here, sitting at my desk, talking to you. If also I were to take this and put in some salt, mix it up, it would be homogeneous, same throughout, or it'd be better sugar and mix it up, it would be homogeneous. Now, heterogeneous is not the same throughout. And you see like 2 layers. Example of that, which I won't do, if I were to put sand in here, but I won't, and I shake it up, you know the sand's going to be at the bottom and the water will be up here, and that's called heterogeneous. And I also showed you Italian dressing, oil vinaigrette dressing, where you have 2 layers until you shake it up. And once you stop shaking it up, it separates again, is heterogeneous. Now, when we talk about matter, there are 2 types of properties you should be familiar with: physical property, chemical property. A physical property describes something that you can observe. Like a physical property of my shirt, it's red. If I were at Glen Ellen main campus and you were with me, we could look out the window at the parking lot across from HSC. That's the chemistry building with other disciplines. And you could count how many red cars, how many green, how many blue. I don't think I've really seen, how many people have seen a yellow car? I don't think they're that often. But anyways, that would be a physical property. Now, a chemical property describes the ability of a chemical or substance to change. An example of that would be a iron can rust. A physical property or chemical property of water, it will not burn. I hope not. Firemen use this to put out fires. But a chemical property, gasoline is very flammable. Now, the next thing is changes in matter. And here, a physical change is when something changes how it looks, goes from one state of physical state to another. If I take and melt an ice cube, it's going from solid water to liquid water. That's a physical change. If I take water and boil it, it's going from a liquid to a gas. That's a physical change. And you can do that with other substances too, freeze it or boil it. Now, a chemical change would be when something changes into a different chemical. An example of that is if you see rust on your car, the iron has turned into a different color chemical, rust, which is also called ferric oxide, Fe2. Another example would be one of my favorites, when you burn a candle. The wax is burning in the wick and undergoing a chemical change. And by the way, you learned for today's lab, it's giving off heat and light, and that tells you it's a chemical change happening when you burn the wax in a wick in a candle. Ooh, here's a good chemical change. Next time you eat something, and when I was 2, my mother used to tell me, don't forget to chew your food before you swallow it or you'll choke. I found out she was right. I did choke, and in case you're wondering, I survived. But anyways, when you swallow it, it goes down to your stomach. There are chemicals in your stomach that react with the food, and you have a chemical change going on in your stomach. All right, next I talked about temperature. And temperature, there are 3 scales we use: Fahrenheit, degrees Celsius, and Kelvin, which is not called degrees because it's an absolute scale. Here are the formulas for converting the first one, Celsius to Fahrenheit. You multiply 1.8 times degrees C and then add 32. Next one, going from Fahrenheit to Celsius, takes degrees F minus 32. Remember, do the subtraction first. Then divide by 1.8, and you'll get the final answer, degrees C, Celsius. And the final formula there is to go from Celsius to Kelvin, take degrees C and add 273. Now, on test 1, it will say underneath your name, please use proper significant figures for all calculated answers. All these formulas, 1.8, 32, 32, 1.8, those are exact numbers. They do not play a role in how many significant figures your answer should be. The only thing that does, in the first formula, degrees C tells you how many significant figures your answer should be. Degrees F in the second one. Now, degrees C in the third one, don't forget that's an addition. If you don't do that right, I won't take off points. Now, let me direct your attention to something you should know. In the lecture file of Blackboard, near the bottom, you will see a file cleverly named Chem 1105, test number 1, important information. These are the things you do not have to memorize. And if we look at this, I'm going to give you these 3 formulas. You have to know how to use them, but you don't have to memorize them. Years ago, 3 or 4 years ago, when I was teaching Chem 1105, students would have to memorize this. And I've cut way down, and you'll see next test, way down on the memorization you have to do. And I highly recommend you look at this. These are things you don't have to memorize. Now, next, I talked about scientific notation. And scientific notation is a number Q or whatever times 10 to the n. It's important. Q is never less than 1, never 10 or greater. And you should know how to convert a number to scientific notation. If the number is greater than 10, n in 10 to the n is positive. If the number is less than 1, n is negative. If I look at the clock, it's not n, it's time to take a break. Let's take a 5-minute break. I'll be right back after I get up and stretch, and we'll continue on with test number 1 review. 5-minute break time. let's get going. Let's get back to review. But before we do, remember to do well on test one. Hopefully you've watched the videos of my lectures for the material on chapter 1, 2, 3, and appendix A2 and A4. Also, to do well, and this is really important, on test number 1, you've done the practice problems for chapters 1. I don't think there's practice problem for chapter 2, but I don't know. I don't remember. I don't think there is. Chapter 3 practice problems and the practice problems for appendix A2 and A4. Do those, and after test number 1, you'll know why I call them practice problems. All right, let's continue with the review. Now, we're talking about you should know how to convert to scientific notation. Let's go through a couple of those. And why don't you convert the following number to scientific notation? Your turn. All right, everybody's done. My turn. How do you convert this to scientific notation? If there were a decimal point, you move it to the right of the first non-zero number. 1, 2, 3, 4, 5, 6, 7, 8. We moved it 8 times. When there's no decimal point, zeros at the end are dropped. And now let's write the number 1.245 times 10 to the n. And when it's greater than 10, this number is positive, and we moved it 8 times. So it'd be 1.245 times 10 to the 8th. Oh, let's do another one. These are fun. Why don't you write the following in scientific notation? All right, my turn. Now, once again, move the decimal point, there's 1 here, to the right of the first non-zero number. 1, 2, 3, 4. We moved it 4 times. Lead zeros are dropped. Zeros after decimal, well, we don't have that are not lead zeros are not dropped. Now this number, the leads, the lead zero, we drop. This number is less than 1. When you have a number less than 1, remember it's 10 to the n is negative. Well, we moved it 4 times, so 10 and now -4. And that would be the number you get for scientific notation. Go back and look at the problem set for that. And let's continue on with our review. Now, next I talked about significant figures. Now, how do you determine how many significant figures for a number has? All non-zero numbers are significant. Zeros may or may not be significant. Zeros at the beginning of a number are never significant. Confined zeros, I don't know why I have this again twice, but I do. Confined zeros, those between non-zero numbers are significant. Trailing zeros, those at the end of a number are significant if a decimal point is present in the number. Trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. And on test 1 and 2, 3, 4, and the final, it will say, please use proper significant figures for all calculated answers. So first of all, you have to know how to find how many significant figures are in a number. And the question is, how many significant figures are in this number? Your turn. And it's my turn now. I see one of your colleagues is doing it all right. Yay. All right. All non-zero numbers are significant. So I have 3 right there. Ooh, I've got zeros. They're at the end, but there's no decimal. By the way, PT is short for point. So those are not significant. This number has 3 significant figures. And the question in this number, let me redo it. How many significant figures are in that number? Your turn. And it looks like everybody's done. So it's my turn. All non-zero numbers are significant. Ooh, there's a decimal point. Zeros at the end with a decimal point are significant. So this will also have 3 significant figures. And here's one more for you to try. How many significant figures are in that number? And it looks like everybody's done. My turn. There's a decimal, but lead zeros are never significant. Non-zero numbers are, and there's 1, 2, 3, 4. So this would have 4 significant figures. Now, when you're dealing with significant figures, you have to know how to round off. And if the first digit to be deleted is 4 or less, simply drop it and all add the digits that follow. If the first digit to be deleted is 5 or greater, that digit and all that follows are dropped, and the last retained digit is increased by 1. And why don't you round this off to 2 significant figures? Your turn. Round this number off to 2 significant figures. And everybody's done, so it's my turn. Keep the 3, keep the 6. That's my 2 significant figures. The next number I round off. Is that 4 or less or 5 or higher? And it's 5 or higher. So I'm going to drop this, increase that by 1. This is still there. And why don't you round this one off to 3 significant figures? Your turn. And it's my turn. How do you round it off to 3 significant figures? Remember, there's a decimal point. Keep the 2, keep the 1. Zeros at the end are significant. This is my 3rd significant figure because I asked you to round it off to 3. The next number I use to round off. Is that 5 or greater or 4 or less? And hopefully I'll pick 4 or less. So I'm going to drop that and everything else afterward. You keep this. So the answer is 2.1 times 10 to the 3rd. Now, these are rules you should know. On test 1, I'm going to deal with multiplication, division. Later on, I'll talk about addition. And for multiplication and division, you get the same number of significant figures in your answer as the number with the fewest significant figures in your answer. Again, for multiplication, division, you get the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying and dividing by. And let's take a look at that. And the question is, what would be, and let me fix something up. That looks better. Remember, Dr. White writes the 7 like that. All right, what would be the answer using proper significant figures for that multiplication? 2.1 times 10 to the 5th times 6.453 times 10 to the 7th. I can get my calculator out, clear it. I'm in scientific notation, 2.1 blue double E 5 times 6.453 blue double E 7. And my calculator gives me this number on the screen. Don't forget in the corner here, there's a very little, but it says X and a little 10 and a bigger number, 13. Now, how do you do this? How many significant figures in the first number? All non-zero numbers are significant. 2 significant figure. Second number, all non-zero numbers are significant. That has 4, the first has 2. Remember, you ignore for significant figures 10 to the n. And when you multiply and divide, you get the same number of significant figures in your answer as the number with the fewest significant figures. And If we look here, this is 2, this is 4, which is the lower number, and hopefully you pick 2. So now you have to round this number to 2 significant figures. And how do we do that? Keep the 1, keep the 3, use the 5 to round off. Is that 4 or less or 5 or higher? And 5 or higher. Drop that, everything afterward. And because 5 or higher, I increase that by 1. And you now get 1.4 times 10 to the 13th. Let's do one more. If we divide 3.111 times 10 to the minus 4 by 7.3336 times 10 to the minus 7, what is the answer you get? And don't forget to use proper significant figures. And while you're doing that, I'm going to do it too. That looks like everybody's done. I do it. Don't forget, for a minus exponent, use the key on the keyboard here, bracket minus bracket, not the key over here, which is for minus subtraction. Use this key right here for 10 to the minus whatever. Now my calculator gives me this number. Hold on, it's going to take me a while to write this all. And the question is, what's the proper number using significant figures? Well, you have to figure out how many significant figures this number has. All non-zero numbers significant. 1, 2, 3, 4. How many significant figures does this number have? All non-zero numbers are significant. 1, 2, 3, 4, 5. My number should have the same number of significant figures when you multiply and divide as the number you're multiplying and dividing that has the fewest, significant figures. In this case, it's 4. So how do we round this off to 4 significant figures? Keep the 2. Keep the 4. Keep the 2. Keep the 4. Keep the 1 right here. This 1 would be the number we use to round off. Is that 4 or less or 5 or higher? And 4 or less. So I'm going to drop that. This is a 1 right here. Drop that, that, and that. And the correct answer for this number would be that. All right, let's continue on. Now, when we come to our periodic table, which I don't have open, so I better open it up. When you take test 1, use the periodic table you can download for this test. Don't go on the internet or anywhere else, a book, that's cheating. All right, now, that's not what I want. Now, for the periodic table, you should know the group names: alkali metals, alkaline earth metals, halogens, and noble gases, and know what elements are metals. Now, let's look at the alkali metals and alkaline earth metals, halogens, and noble gases. On our periodic table, except for hydrogen, everything in the first column is the alkali metals: lithium, sodium, and potassium. And you should know how to identify them both by name and chemical symbol. Second column, alkaline earth metals. And the only ones I asked you to learn are Mg, magnesium, Ca, calcium. We go all the way over to the right, the column with the number 7 above it, we have the the halogens, or did the alkaline earth metal, and the halogens are fluorine, chlorine, bromine, and iodine. And finally, the very last column, all the way at the right, with the number 8 above it, are the noble gases. Example would be helium, neon, argon, and krypton, and xenon. And you should know that. Now, next we had some fun. We started talking about chemistry, like the atom. And you should know that's the smallest particle of an element that has all the properties of an element. Now, atoms are made up of subatomic particles. And you should know there's the electron, the proton, and the neutron. Again, the particles that make up the atom, called subatomic particles, are the electron, proton, neutron. You should know electrons have a minus charge. You should know protons have a positive charge, and a neutron has no charge. Now, when we talk about atoms, the nucleus of the atom, you should know, is the center of the atom. You should also know the nucleus only contains protons and neutrons. Again, let me remind you, what you see on the screen is available in the lecture section of Blackboard, cleverly named Chem 1105, test number 1 review. And you should also know that Rutherford's gold foil experiments help clarify. Clarify is a fancy word for figure out or understand that the nucleus, which is very dense, contains only protons and neutrons. Next, the atomic number. The atomic number, you should know, is the number of protons in an element, and because all elements, atoms, have a net zero charge, it's also number of electrons in an element. And if we look at the periodic table, you'll see the atomic number is in the upper right-hand corner of each box. And for Li, lithium, the atomic number is 3. That means it has 3 electrons, 3 protons. If I go over to my favorite element, carbon, organic chemists love carbon, you see C, carbon, in the upper right-hand corner, the number 6, and that tells you it has 6 electrons, 6 protons. We go down to I, the halogen iodine, you see the atomic number 53. So iodine has 53 electrons, 53 protons. And you should be able to do that for all the elements that I asked you to learn. Now, next, if the protons and neutrons are in the nucleus, where are the electrons? They're in the electron shells that surround the nucleus. And the shells are numbered 1, 2, 3, 4. And you can see in this chart the number of subshells. Shell 1 has 1, 2, 2, 3, 3, and so on. What I don't have, but you're going to have to remember, this chart goes from low down to highest energy electrons in those shells. Now, each shell has subshells, and they're labeled S, P, D, and F. But remember, a subshell is really a number and a letter. Shell 1 subshell is 1S, number, letter. Now, here again, starting at the top, any S subshell is the lowest energy. And as you go down, this is the highest energy. And you always fill the lowest shell and subshell before it with all the electrons you can put in there based on the number of subshells and the number of electrons the subshells it has, you can put in. I don't have on here, but I have it on test 1. Those numbers are the maximum number of electrons you can put in a subshell. Now, I showed you how to do electron configuration. And that's a statement of electrons, how many electrons an atom has in its shells and subshells. Hint, number, and letter. Yesterday's video, I went through a number of these. Well, let's do one more. And let's draw the electron configuration for the element oxygen, or atoms of oxygen. And how do you do that? Well, first of all, you have to know how many electrons you have. And if we look at oxygen, O, the upper corner, the atomic number tells you how many electrons and protons, and that's 8. So oxygen has 8 electrons, and I abbreviate electrons like that. Now, what's the first shell and subshell you can put in electrons? And if you look at important information, test number 1, you don't have to memorize these two charts, but in the past students did, but you don't. Thank you, Dr. White. You're welcome. And the first shell, the lowest energy is 1. It has one subshell, S, 1S. Remember, a subshell is a number and a letter always, and you can put a maximum of 2 electrons. So let's go and do that. The first lowest subshell and shell is 1S. And I put 2 electrons. Well, 8 minus 2 is 6, so I've got more to go. Well, shell 1, you can only put 1 subshell, 2. And 1S, you can only put 2 electrons. And shell 1 has 1 subshell. I filled it up. I have to move down to the next highest energy level, 2, or shell 2, and it has 2 subshells. The first subshell is 2S, And the second subshell, the two shells of shell 2, say that 5 times quickly what I just said, is 2p. And 2s, you can put 2 maximum, 2p, you can put 6. So let's go to that. So I have to go to the second shell, the first subshell. Remember, subshell's number letter, 2s. I can put up to 2 electrons. I will. Well, 8 minus 4 equals 4. 2 has 2 subshells. First one is 2s. Second one is 2p. As you saw from the table, I can put up to 6 electrons in any p subshell. But today I only need 4. And I'm done. And the answer is 1s2, 2s2, 2p4. And that would be the electron configuration for oxygen. Don't forget my gift. Shh. You only have to know how to do electron configuration up to magnesium atomic number 12 for my class. Hint, you only have to know how to do up to magnesium for the atomic number. And let's move on. And finally, let's talk about the valence electrons. You should know the valence electrons are the outermost electrons of an element or an atom. Valence electrons are the outermost electrons of an element. And how do you find the valence electrons? You see the top number I have in red. They're in Roman numerals, but most students I've found a couple of years ago were never taught Roman numerals. Why? But anyways, that's sad. But still, so I put in. Remember, you can only have a maximum of 8 valence electrons. If we look at our periodic table here, we have lithium, 1 valence electron. Remember, valence electrons are not from the atomic number. The atomic number gives you all electrons. Valence electrons are the outermost electrons of an element, and you can only have maximum 8. So I say, how many valence electrons does chlorine have? Cl, halogen. No, not 17. That's all electrons. You look at the top, and in red, unless you can read Roman numerals, which I can, most of you can't, sad but true, it's 7. Chlorine has 7 valence electrons. If I ask you, how many valence electrons does krypton have? What's the chemical symbol for krypton? Kr. You look at the top, it's a noble gas. It has 8 valence electrons. Let me move the video. See, 8. And that's how you figure out how many valence electrons. And with that, I'm done with the review. I'll have to go back to my periodic table. I think so, but those are elements I never deal with. Well, boron I have, but the other one, I'm not sure because I just don't deal with that. Sometimes you can have more than one type of valence electrons, which I'm not getting into in this class. But I would think so, but that should have the same. Because we're dealing with only S and P subshell electrons in valence, and that's why I also didn't ask you to learn the how should I say, other elements, because the rules break down, you have to learn the exceptions. All right, any other questions? Remember, do the practice problems. It will help you do well on test 1. Trust me, I'm a doctor. Did that work? How about trust me, I'm an organic chemist? Did that work? How about trust me, I write the test? I bet that worked. All right. Well, we got a couple minutes left to go. Let's go back to, that's not what I want. Interesting. I don't have it open. Well, I had a lot of other stuff open. Now, yesterday I taught you about different types of covalent bonds. And you should know single bond involves 1 pair of electrons, double bond, 2 pair, and triple bond, 3 pair. And in class, we did these 3 examples, and this is all material for test 2. So after test 1, you should start doing the practice problems for chapter 4. And let's move on. Now, it turns out molecules have shapes, just like people. Molecules exist in 3 dimensions, and they have shapes. Now, there's something called VSEPR. And VSEPR, by the way, click switches off for the previous slide and this slide, and next couple, this will not be on a test, but still something good to learn. And VSEPR stands for valence electron pair repulsion theory. And the VSEPR theory explains why molecules have different shapes. And the way this happens is electrons don't want to be near other electrons in other shells and subshells or bonds in a chemical bond, the valence electrons really. And so they want to be as far apart. And this determines the shape of a molecule by how many chemical bonds it has, or the type too, and how many non-bonding electrons it has. And it's based on the pair of electron pairs bonds of an atom. Now here I have CH4, which is methane, natural gas. It's tetrahedral. Click, switches off. Here I have ammonia, and that's trigonal pyramidal. And part of this is because of the non-bonding pairs of electrons. And water isn't a straight molecule, it's bent. Now, if you look at your screen, there's this beautiful table created in Wikipedia. And let's look at here, 4. We have 4 pair of electrons. Now, in the first one, A is the center element and X are other elements. And you have 1, 2, 3, 4. I'm not going to teach in this class, but the wedge and the dotted line show you stereochemistry, tell you the X is coming towards you, the other one is going behind the paper or screen. Now, if you have a non-bonding electrons, where this is represented by the letter E, then if you have 3, like an NH3, A is N, the X's are H, then you don't see this, but you see this, and it looks pyramidal, trigonal pyramidal. And finally, where it's bent, water, center oxygen, X and X are hydrogens, 2 single bonds, and the E's are the 2 pair of electrons on the oxygen. And that would be water, and that's bent. Water is not straight, it's bent. Next time you're drinking water, you're drinking bent molecules. Again, switches off. Speaking about switches off, I just looked at the clock, and we're done for today. Doesn't time fly when you're having fun with Dr. White and a test review in a lab? Don't forget, today's lab, I've expended a period. Normally it would be due Thursday. I've given it you till Saturday to do it because there's a lot of work. When you do today's lab, don't do it on a marble top. Some of the chemicals will damage a marble top in your kitchen and other surfaces. Spend a couple of, I think I said 2 pans are $1.24 plus tax at Walmart, and that will protect the thousands of dollars somebody spent for a marble top in your kitchen or the other type of tops. Remember, wear your safety goggles for today's lab when you do it, and gloves. All right, with that, I'm all done for today. Remember, tomorrow night, I have my office hour. So if you have any questions, come to my office hour tomorrow night, or come to our lecture. And after lecture, if you have questions about test number 1 and your material, I'll answer them. And with that, I'll say, Gehen gesund. Somebody beat me to it. Gehen gesund. Goodbye now. I stole that from Granny and the Beverly Hillbillies. Bye.